let's do some stats. So we are going to talk about measures of position now. It's basically a way to compare two different sets of data. Okay, for instance, if, let's just say I gave a stats test and Mrs. Keller gave an Algebra 2 test. And we were trying to compare who did better. Can we really just look at the mean on those? No, because it's two different tests, right? There's a different mean, different standard deviation. We have to be able to compare. Or if I want to know, like, who is relatively taller between Abram and Anna? Okay, there's a difference between males and females in general, right? So can I just compare their two heights and say that? No. So we have to be able to take different sets of data and get a common unit in order to be able to compare them. And that calculation is called a z-score. If you have your formula sheets, you're probably just going to want those every day. It's the next two bullets. So we are on the second column of chapter 3. If you skip, it's like the z-score. So it's the second column, like towards the bottom. Population z-score and sample z-score. Because we skipped a bunch of stuff in the previous section. So, the calculation is really the same. It finds a z. Look under the population formula. X minus what's mu represent? The mean. What's sigma? Oh, you're thinking variance is sigma squared. That's just your standard deviation. So this is the mean of the population. This is standard deviation of the population. Okay, with the sample, x minus x bar. What's x bar? It's the mean of a sample. What's s? Standard deviation of a sample. Okay, that's all we're going to do. We're going to subtract the mean, divide by the standard deviation. What this will tell us is how far things are from the mean in terms of standard deviations. So if I get a z of positive 2, that tells me my value is 2 standard deviations from the mean. Okay, if you think about our bell curve, I think you have a blank one on your paper we haven't used. If I get positive 2, that means you're out here. So you're higher than average, right? You're 2 above the mean. If I got a z of negative 1.5, what would that tell me? Yeah, you're down here. So you are below the average. Okay, 1.5 below. So z is telling you how many standard deviations you are from the mean. And we can use that to compare sets of data. So let's look at an example to make some sense of it. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8. Okay. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7. Who is relatively taller? So I have two people here. Can we agree they're both taller than average? Yes. But if I'm going to decide who is taller in comparison to their group, we have to get your z-scores. So your z is just your value. So for Kevin, how tall is he? Minus the mean of his group. What's the mean for the males? Divided by the standard deviation of his group. All right. So if we calculate that, 2 decimal places is fine on these. And I get a z of 4.96. What does that mean?
Above average.
Put this in parentheses when you type it in. So he's almost 5 standard deviations above the mean. Think about that. If I'm looking at this curve, that's all the way out here. So that's pretty tall in comparison to the average, right? Now let's look at the next one. So for the females, her Z, what is her height? Minus, what's the mean of the female group?
62.
Divided by standard deviation of that group. Okay, so let's do this. So we get 4.56. So she is 4.5 standard deviations, but who was more? Right, Kevin was taller in comparison to his group because he was further from the average.
So in theory, couldn't you also take 83 divided by 69, and that would give you like, maybe it would give you like 1.2 something or other.
Mm-hmm.
And then if you did that also for the females, it would give you a different 1 point something or another. And then you'd be able to tell who was taller relatively. And that would, I don't know, this may already do that, but that would take into account that an inch is different because a female is smaller than a male. So
Right.
an inch that a male is taller is less of a big deal as an inch that
Right.
a female is taller.
So it would tell you which one is further from the mean, but it disregards the standard deviation, which can be impactful on some.
Gotta be honest here, brother.
So we do still have to divide that part.
You just
You
completely
just
lost
ChatGPT
me.
and I just lost it out.
Yeah.
I did not understand
I actually have
what
a-
you said.
Why couldn't you just like subtract 83 minus 6.5.1 to like figure out like total distance from the average height?
Hey, that's exactly what he was saying.
Oh, you just made that way more confusing.
So what that doesn't take into account, it takes into account like who is further from average, right? But what it doesn't use is the standard deviation. So if your standard deviation is really big, that means all your data is really spread out. That is different from a group where the standard deviation is really small and almost all the values are close together. So that's why we have to divide the standard deviation.
Thank you, April.
You made that way more confusing something.
Ooh,
Like, the inch is smaller here than the
AI is like saying,
See, this is why we need a mental day.
All right, let's take a look at this. We can also find percentiles. You've probably heard of percentiles before. Any standardized test you've ever taken, they tell you your percentile. If they come back and say you scored in the 82nd percentile, what does that mean?
My head's not here.
If it was out of 100, you were better than 82.
Right. Basically, 82nd percentile means that 82% of the scores were less than or equal to yours. Okay? So we can find our percentiles, like 99th percentile means you only have 1% that was better than you.
That's how bad to be in the top like 5.
Everything's
5
down
to
here.
50.
Oh, yeah.
That would be really bad.
Yes.
This
How do they
circle
say it
is
when they say it the other way? Because sometimes it's like you want to be in the.
wait, so
Lower.
what's that again?
Well, sometimes it's good.
Oh,
There's
my
another way to
head's
say
like
it's not
100,
percentile,
like,
but it's
I'm
like
bigger than what it should
same
be.
thing. basically.
No, not that.
90.
It's just like
Yeah.
Where's
They
the
could,
other
usually
people?
there's not like a
Yeah.
stats.
Wait,
bar.
I'm
big-
You'll just say it.
Yeah.
And words.
Well, you said like on the chart, you know how
I
it
don't
goes.
understand. Okay, wait.
You know
Okay.
how
Okay. So it's just a notation thing. If you see like a P sub 10, that means the 10th percentile. So that means 10% were less than or equal to that value. So 90% would be larger. So, for example, the GRE is a test required for admission to many grad schools. University of Pittsburgh requires a GRE score of no less than the 70th percentile for admissions into their human genetics program. Interpret this. So what does that mean if you have to have a score in the 70th percentile?
pretty good score.
Yeah, I'd be better.
It's gotta be better than 70% of
Okay.
the mistake.
The
C
score
minus-
must be yeah, I'll say high enough that at least 70% of the score Or another way of saying it, how many can be better than you?
30.
Only 30% can be better than you. So 70% are less than or equal to that score, 30% better.
Feel made fun of. I feel insecure. Body does that right.
There's a blue marker. We can draw a picture of you on the.
It's like I need to remember five.
Greater than or equal to.
I've heard that my whole
We
life.
want it to be more than 70%.
He's the true stick man, where the head
Yeah.
is like.
Well, no, I wouldn't
This
say
page
that.
taught me alligator,
It was just large.
and
Yeah.
I can
Really
remember
big.
my dyslexia. I never can remember
Oh.
which
Sorry,
side,
dyslexia
which
is not
way.
So
it
think
goes.
about the bigger part of the symbol goes towards the bigger number.
That's what I think all the time. But if it's greater than or less than, then I don't know because there's only one
Oh,
number.
okay, you don't know.
I don't know how it works.
I see.
Off my head.
Quartiles are a type of percentile. They just divide your data into fourths. So quartile 1 would be the same thing as what percentile? Yep. Quartile 2 is the 50th percentile, also known as the median. Quartile 3 would be the 75th percentile, and your largest one, your 100th percentile. Everything is, if I ask for a quartile, they divide it into fourths. Yep, it's just
So is
breaking
that
into
like
fourths.
a special baby.
Yes.
I could have gone down to the record books.
You might
The
be in
Guinness
there.
World Record.
First baby to ever have 100 percentile.
Okay, so we have a group of students collected data on the speed of vehicles traveling through a construction zone on a highway, where the posted speed was 25 miles per hour. The recorded speeds of 14 random vehicles are given below. Find the quartiles.
40's like Nair. She was driving really fast yesterday.
You weren't even in the car.
Okay,
Yeah. Me and Toby had to go like 90 just to get past.
Are we all going?
Thank you for admitting.
all right, we're doing stats now. Let's start with quartile 2. What's the quartile 2 also known as?
50.
50th percentile, or the median. Okay, we've done that before. I was nice and I already put your data in small to large order. Okay, so to get my second quartile, what would I have to do?
What is the line in the middle?
That was just the middle, yeah.
Divide them by 2, so 27.
32.5.
Wrong one. I was saying it, yeah.
Yeah, you're going the other way. Okay, so here's the middle. Okay, my second quartile is right in between those. So there are 7 points below. The first quartile, think of it as just the median of this bottom half. All right, so out of these 7 points, the middle point would be 28. And just like with the other one, if we had 2 points there, we would average them.
Wait, not 20 was the middle of which numbers?
The bottom half. So I drew a
Oh.
line separating the data in half.
Yeah. I don't know that.
And so
77.
the third quartile would be.
Because
It's the middle of the right half.
Oh.
What if there's only
So,
I thought we were
second
skipping
What?
those 30.
what if there's only one middle number?
Then it would just be one.
Or like
If there were
Alright,
two numbers
what's
in
the
the middle,
speed?
you would average
25.
just like you did.
25.
I'm probably more on
So
the
this is
back half.
This is a median.
Yeah, basically it's the median of the bottom half, the median of the upper half. So, what this means, first quartile means 25% of the speeds were less than or equal to 28. 50% of the speeds were less than or equal to 32 and a half. 75% of the speeds were less than or equal to 38. Okay, does that make sense, what those are telling us? Interquartile range is the range of the middle 50% of our data. It's how spread apart that middle half is. And it's just quartile 3 minus quartile 1. Your calculator will give you quartiles just like it gives you the median. So quartiles are on the calculator. Interquartile range is on the formula sheet. If I wanted my interquartile range for the speed data, so the IQR, what was my quartile 3? Minus my quartile 1. So 38 minus 28 is 10 mile per hour. So there is a 10 mile per hour difference for the middle 50% of our data. That's the difference between the first and third quartiles. car travels through the construction zone at 100 miles per hour. How does this value impact mean, median, standard deviation, and interquartile range? Okay, did we even calculate all this stuff to begin with? No, so let's do that. Let's enter it on our calculator. Are you really sighing at me? Let's just start with our original points.
Is this just going in L1?
Yes.
All of those numbers?
Yes.
One variable or two?
One variable since everything's in the one list. So let's do. Okay, so the original, what was my mean?
32.
Okay. The median, remember that's on there, and you see it, it's right in between quartile 1 and quartile 3. You scroll down, which isn't that what we already found for the second quartile? Did you see it? Use your down.
Oh.
So is this, in this one, where we're supposed to put 100
No,
on the bottom?
not yet. Standard deviation, is this a population or a sample?
Should be population.
Is it,
Sample.
we only looked at 14 cars that drove through, so not everybody. So our sample standard deviation, that's S, so 6.175. Interquartile range, we already found was 10, but you can also get it on your calculator. Look, Q3 is 38, Q2, or Q1 is 28. You just subtract them. Now let's look at our new one. So, I want you to go to your list and add 100 miles per hour at the bottom. And then we're going to calculate our one variable statistics.
Add it to L1.
Yeah. What's our new mean?
36.
Okay, median 33. Standard deviation, that's still S. So 18.504. What's the IQR this time?
112.
Okay. How do we find interquartile range?
It's just gonna go up.
Yeah, it's Q3 minus Q2,
Oh.
and it's 11. What were you doing, range?
I was thinking we did 100 minus that.
Oh. Okay,
Right.
so what I wanted you to notice, look at the mean. What happened? It went up, a little or a lot? A little, but in terms of, in comparison to the other numbers, it's a fairly large change. What about our standard deviation? Went up a lot. Okay, there is a huge difference between a standard deviation of 6 and a standard deviation of 18. So, we see the mean and standard deviation had larger changes. Okay, what about the median? Yeah, only 0.5. IQR went up by 1. Are those big changes? No. So the median and the IQR had a small change. What did we call that? When a large value doesn't change it a whole lot. So that means, in general, mean and standard deviation are great ways to describe our data, but those things are easily influenced by a really large or really small value. If you have those extreme values, then your median and interquartile range are going to be more reliable. And that's what I just put on the next slide. So our shape, if it's symmetric, the measure of central tendency, that's the middle. We go with the mean. Measure of dispersion, how spread out we are, we go standard deviation. If our data is skewed, these numbers get changed a lot, so we want to go with the median and interquartile range. I think I'm going to go ahead and stop here. Tomorrow, I am just going to talk about outliers. So, what is a really big or a really small value? We might do just a couple of review things as well tomorrow. And then I'm going to go ahead and give you this handout. It is one assignment for today and tomorrow. So this handout is due Wednesday. So you've got a little bit of time right now and you'll have more time tomorrow.